you can start the ellipse. Now, if suppose there is a fixed point, S is a fixed point, L equals to 0, a fixed line, L equals to 0, fixed line, P is a variable point. Now, the distance between fixed point and variable point P is SP, and perpendicular distance from P to fixed line L equals to 0 is PM. If SP by PM is less than 1, SB by PM is less than 1, then the locus of the point P is an ellipse. The locus of the point P is an ellipse. Here SP by PM nothing but eccentricity. Eccentricity less than 1, the locus of the point P is an ellipse. Now, the standard equation of the ellipse is x square by a square plus y square by b square equals to 1. The standard equation of the ellipse is x square by a square plus y square by b square equals to 1. Now, in this case, if suppose a greater than b, in this case, the major axis of the ellipse is x-axis. Now, x-axis is major axis, y-axis minor axis. Now, the points of intersection of ellipse and major axis A dash are called vertices. A dash are called vertices. Now, point of intersection of major and minor axis is called center. C is center and B dash ends of the minor axis. B dash ends of the minor axis. Now, the length of the major axis A dash equals to 2A. Length of the major axis A dash equals to 2A. Similarly, length of the minor axis B dash equals to 2B. And S and S dash are foci. S and S dash are foci of the ellipse. Now, S and S dash are always foci of the ellipse lies on the major axis. Now, one focus S equals to AE, 0. Second focus S dash is minus AE, 0. Minus AE, 0. Second focus. One focus AE, 0. Second focus minus AE, 0. Similarly, vertices A, 0. Second vertex minus A, 0. Ends of the minor axis 0, B. Second end 0, minus B. Now, a chord passing through focus and perpendicular to axis, perpendicular to major axis is called latus rectum. Now, L dash is latus rectum. Length of the latus rectum L dash equals to 2b square by a. 2b square by a. And ends of the latus rectum L and L dash coordinates AE, b square by a. In fourth quadrant AE, minus b square by a. Also, second latus rectum in second quadrant end of the latus rectum minus AE, b square by a. In third quadrant minus AE, minus b square by a. Now, ends of the latus rectum plus or minus AE, plus or minus b square by a. Plus or minus AE, plus or minus b square by a. 4 ends. Now, if suppose the ellipse equation x square by a square plus y square by b square equals to 1 and b greater than a, b is greater than a, in that case the ellipse is a vertical ellipse. Vertical ellipse. In that case, y axis is major axis, x axis minor axis. Next to B and B dash are vertices. P and B dash vertices. A and A dash are ends of the minor axis. A dash ends of the minor axis. C is the center. C center. Now, foci of the ellipse lies on the major axis or y-axis. Now, in that case, ends of the minor axis A, 0 minus A, 0. Center 0, 0. One focus 0 comma BE, second focus 0 comma minus BE. Now vertex is 0 comma B, 0 comma minus B. Now two directrices Z and Z dash are feet of the directrices. Its coordinates 0 comma B by E, 0 comma minus B by E, and equations of directrices x equals to plus or minus B by E. Now one directrix x equals to B by E, second directrix x equals to minus B by E if B greater than A. If ellipse equation x square by A square plus y square by B square equals to 1 and A greater than B, now eccentricity E equals to square root of A square minus B square by A square. Eccentricity E equals to square root of A square minus B square by A square if A greater than B. If suppose B greater than A, in that case E equals to square root of B square minus A square by B square, B square minus A square by B square. Next, if suppose the ellipse equation x square by A square plus y square by B square equals 1, standard equation, if slope of the tangent is M, now equation of the tangent, or if y equals to mx plus c, if y equals to mx plus c is a tangent to the ellipse x square by A square plus y square by B square equals to 1, then c square equals to A square m square plus B square, c square equals to A square m square plus B square. Now next, if suppose the ellipse Px1 y1 lies outside of the ellipse, from external point two tangents can be drawn to the ellipse. If suppose slope of the tangent is m, then equation of the tangent in the slope form y equals to mx plus square root of A square m square plus B square. Y equals to mx plus square root of A square m square plus B square. But tangents passing through x1 y1, then y1 equals to mx1 plus square root of A square m square plus B square. Now mx1 taken left side and squaring on both sides, y1 minus mx1 whole square equals to A square m square plus B square. Now complete simplifying, we get x1 square minus A square into m square minus 2x1 y1 m plus y1 square minus B square equals to 0. Now it is a quadratic equation in terms of m. It having two roots. The roots consider m1 and m2. Now m1 is slope of one tangent, m2 slope of the second tangent. m1 slope of one tangent, m2 slope of the second tangent. Now but m1 and m2 are roots of this quadratic equation, then sum of slopes m1 plus m2 equals to 2x1 y1 by x1 square minus A square. Sum of slopes equals to 2x1 y1 by x1 square minus A square. Similarly, product of roots or product of slopes equals to C by A, y1 square minus B square by x1 square minus A square. Now sum of slopes equals to 2x1 y1 by x1 square minus A square. Product of slopes equals to y1 square minus B square by x1 square minus A square. If suppose the angle between the pair of tangents 90 degrees, then product of slopes equals to minus 1. Then minus 1 equals to y1 square minus B square by x1 square minus A square. Now cross multiplication, minus x1 square plus A square equals to y1 square minus B square, or x1 square plus y1 square equals to A square plus B square. Now locus of x1 y1 is x square plus y square equals to A square plus B square. Now it is a circle. Now the locus of point of intersection of perpendicular tangents to the ellipse is a circle which is concentric with the given ellipse. Then this circle is called director circle of the given ellipse. Directed circle of the given ellipse. Now directed circle equation x square plus y square equals to a square plus b square. If suppose ellipse equation x square by a square plus y square by b square equals to 1. Now Px1 y1 is a point on the ellipse. Px1 y1 is a point on the ellipse. Then equation of the tangent at the point Px1 y1 is s1 equals to 0. If suppose the equation of the ellipse is s equals to 0, then equation of tangent at x1 y1 is s1 equals to 0. Similarly, equation of the normal is a square x by x1 minus b square y by y1 equals to a square minus b square. It is equation of the normal. Equation of the normal at x1 y1 is a square x by x1 minus b square y by y1 equals to a square minus b square. If suppose a straight line Lx plus my plus n equals to 0, Lx plus my plus n equals to 0 is a tangent to the ellipse x square by a square plus y square by b square equals to 1, then the condition a square l square plus b square m square equals to n square. Lx plus my plus n equals to 0. The straight line Lx plus my plus n equals to 0 is a tangent to the ellipse x square by a square plus y square by b square equals to 1. Then the condition a square l square plus b square m square by equals to n square. And the point of contact minus a square l by n, comma minus b square m by n. Point of contact minus a square l by n, comma minus b square m by n. Next, the parametric equations of the ellipse x equals to a cos theta, comma y equals to b sin theta. At the point theta means a cos theta, comma b sin theta, a cos theta, comma b sin theta. Now equation of the tangent to the ellipse x square by a square plus y square by b square equals to 1 at the point theta is x by a cos theta plus y by b sin theta equals to 1. Equation of the tangent at the point theta. Now similarly, equation of the normal at the point theta is ax by cos theta minus by by sin theta equals to a square minus b square. Equation of the normal at the point theta is ax by cos theta minus by by sin theta equals to a square minus b square. Now we can do some problems on the ellipse. First problem, the equation of the ellipse whose focus at 4, 0, whose one focus at 4, 0 and whose eccentricity 4 by 5, eccentricity 4 by 5. Now required equation of the ellipse in the standard form, given one focus 4, 0, focus 4, 0, eccentricity E equals to 4 by 5. Now center 0, 0, center 0, 0. Now always distance between center and focus CS equals to AE, but that equals to 4. Now AE equals to 4, AE equals to 4, E equals to given 4 by 5, A into 4 by 5 equals to 4, then A equals to 5. 4 get cancel by cross multiplication, A equals to 5. A equals to 4, A equals to 5. But in ellipse, B square equals to A square minus A square E square. But the value of A equals to 5, A square equals to 25 minus A square E square. A equals to 4, A square E square equals to 16. Now that equals to 9. Now B square equals to 9. A equals to 5. Now required equation of the ellipse in the standard form, x square by A square nothing but 25 plus y square by b square 9 equals to 1. Now x square by 25 plus y square by 9 equals to 1 is the required equation of the ellipse. Now second option, x square by 5 square plus y square by 3 square, or x square by 25 plus y square by 9 equals to 1. Second option is the correct. The equation of the ellipse whose vertices 2, minus 2, 2 comma 4, 2 comma minus 2, 2 comma 4, and eccentricity 1 by 3, eccentricity 1 by 3. Now observe the given points. In 2 points x coordinates equal, x coordinates equal. Now in 2 points x coordinates are equal, the line segment joining 2 points parallel to y axis, means in that case the ellipse is a vertical ellipse, not horizontal ellipse. Given vertices, one vertex 2 comma 4, second vertex 2 comma minus 2, 2 comma minus 2. Now center of the ellipse, center always midpoint of vertices, center of the ellipse equals to midpoint of vertices, that equals to we get 2 comma 1, midpoint of 2 comma 4, 2 comma minus 2. Now midpoint formula x1 plus x2 by 2 comma y1 plus y2 by 2. By applying that formula we get center 2 comma 1, center 2 comma 1. Now always the distance between center and any one of the vertex, center and any one of the vertex equals to half of the major axis, half of the major axis. Now distance between 2 comma 1 and 2 comma 4 is 3 units, but vertical ellipse half of the major axis or semi major axis equals to b. Now b equals to 3, b equals to 3. Now eccentricity 1 by 3. Now for vertical ellipse a square equals to b square into 1 minus e square, a square equals to b square into 1 minus e square. Now a square equals to, here the value of b square equals to 9 into 1 minus e square 1 by 9. Now that equals to 8. The value of a square equals to 8. If suppose center h comma k, center h comma k, the equation of the ellipse x minus h whole square by a square plus y minus k whole square by b square equals to 1. Now here center 2 comma 1. Now x minus 2 whole square by a square 8 plus y minus 1 whole square by b square equals to 9 equals 1. The required equation of the ellipse is x minus 2 whole square by 8 plus y minus 1 whole square by 9 equals to 1. Now fourth option is the correct, fourth option. The equation of the ellipse with its axis as coordinate axis respectively and whose minor axis 6, eccentricity 1 by 2, eccentricity 1 by 2. Now given the axis of the ellipse or coordinate axis, means major axis x axis, minor axis y axis. Length of the minor axis given 6, length of the minor axis equals to 2b. Now 2b equals to 6. Now b equals to 3, b equals to 3. Eccentricity of the ellipse e equals to 1 by 2 given. Now required equation of the ellipse. Now b square equals to, in horizontal ellipse b square equals to a square into 1 minus e square, but b equals to 3, b square equals to 9, 9 equals to a square into 1 minus e square 1 by 4. Now 9 equals to a square into 3 by 4, 3 times cancel, by cross multiplication a square equals to 12, a square equals to 12. Then the equation of the required ellipse is x square by a square nothing but 12 plus y square by b square is 9 equals to 1. The required equation of the ellipse x square by 12 plus y square by 9 equals to 1. Then fourth option is correct, fourth option. The equation of the ellipse whose vertices are minus 4 comma 1, 6 comma 1, minus 4 comma 1, 6 comma 1, whose focus lies on the line x minus 2y equals to 2, x minus 2y equals to 2. Now vertices of the ellipse given minus 4 comma 1, 6 comma 1. In given 2 points y coordinates equal, then the line segment joining 2 points parallel to x-axis. Parallel to x-axis. In that case, the major axis of the ellipse parallel to x-axis. Now, vertex is minus 4, 1, 6, 1. Now, center of the ellipse, it is nothing but midpoint of vertices. Midpoint of vertices. Now, midpoint of minus 4, 1 and 6, 1 is 1, 1. 1, 1. Now, center 1, 1. And always the distance between center and any one of the vertex is length of the major axis. Here, length of the major axis to A, half of the major axis equals to A. Now, A equals to the distance between 1, 1, 6, 1. That is nothing but 5. A equals to 5. Now, one focus lies on the line x minus 2y equals to 2. One focus lies on the line x minus 2y equals to 2. Now, equation of the major axis or equation of the line passing through minus 4, 1, 6, 1 is y equals to 1. Because in 2 points y coordinates equal, then equation equals to y coordinate of any one of the point. Now, by solving the equations y equals to 1 and x minus 2y equals to 2, we get focus. Now, y equals to 1 substitute, x equals to 4. Now, focus is 4, 1. One focus of the ellipse 4, 1. Now, the distance between focus and center, CS equals to AE. Now, distance between 1, 1 and 4, 1, that equals to 3. AE equals to 3, A equals to 5. Now, B square equals to A square minus A square E square, or A square into 1 minus E square. Now, A square equals to 25 minus B square equals to A square E square equals to 9. Now, B square equals to 16. Center 1, 1 given. Now, equation of the required ellipse x minus 1 whole square by A square 25 plus y minus 1 whole square by 16 equals to 1 is the required equation of the ellipse. X minus 1 whole square by 25 plus y minus 1 whole square by 16 equals to 1. First option is the correct. First option. The center of the ellipse 4x square plus 9y square minus 24x plus 36y minus 72 equals to 0. The required center of the ellipse. Actually, the given equation converted in the form of x minus h whole square by a square plus y minus k whole square by b square equals to 1. After that, center of the ellipse is h comma k. But the given equation converting in this form, very lengthy process. Now, the given equation consider s equals to 0. The given equation of the ellipse consider s equals to 0. Now, differentiate partially with respect to x. Dou s by dou x equals to 8x minus 24 equals to 0. For implies we get x equals to 3. Similarly, differentiate partially with respect to y. Dou s by dou y 18y plus 36 equals to 0. For implies y equals to minus 2. Then center equals to 3 comma minus 2. Center of the given ellipse 3 comma minus 2. First option. The foci of the ellipse x minus 1 whole square by 5 plus y minus 5 whole square by 9 equals to 1. The foci of the ellipse. Now, the given equation in the form of x minus h whole square by a square plus y minus k whole square by b square equals to 1. But here b square is greater than a square. B square greater than a square. Then, in that case, foci of the ellipse h comma k plus or minus b. H comma k plus or minus BE. Here h comma k equals to center, that equals to 1 comma 5. Center h comma k equals to 1 comma 5. Now BE equals to plus or minus square root of b square minus a square. BE equals to plus or minus square root of b square minus a square. Now that equals to plus or minus square root of b square nothing but 9 minus a square 5. That equals to plus or minus 2. Plus or minus 2. Then foci h comma k plus or minus b. H nothing but 1 comma 5 plus or minus 2. 5 plus or minus 2. If suppose taken plus sign, we get 1 comma 7 is one focus, minus sign 1 comma 3. Now the foci of the ellipse, given ellipse 1 comma 7, 1 comma 3, 1 comma 7, 1 comma 3. Now fourth option is correct. The length of the major axis of 3x square plus 4y square plus 6x minus 8y minus 5 equals to 0. Now required length of the major axis of the ellipse. Now the given equation converted into standard form in 3x square plus 6x, 3 common x square plus 2x plus in 4y square and minus 8y, 4 common y square minus 2y minus 5 equals to 0. Now 3 into x plus 1 whole square minus 1 plus 4 into y minus 1 whole square minus 1 minus 5 equals to 0. Now 3 into x plus 1 whole square plus 4 into y minus 1 whole square equals to, now 3 into minus 1 minus 3 minus 4 minus 5, take right side. Now we get minus 3 minus 4 minus 7 minus 5 minus 12, taking right side we get 12. Now x plus 1 whole square by 4 plus y minus 1 whole square by 3 equals to 1. Here a square is greater than b square, because the value of a square equals to 4, b square equals to 3. A square equals to 4, b square equals to 3. Now a square equals to 4, then a equals to 2. Now length of the major axis equals to 2a. Length of the major axis equals to 2a. Now that equals to 4. Length of the major axis equals to 4. Third option. Third option is correct. The distance between foci of the ellipse x equals to 3 cos theta, y equals to 4 sin theta. The distance between foci of the ellipse x equals to 3 cos theta, y equals to 4 sin theta. First to eliminate theta from these two equations, we get the required ellipse. Now x square by 9 plus y square by 4 equals to 1. 16. X square by 9 plus y square by 16 equals to 1 is the ellipse equation by eliminating theta from two given equations. Now in this b square equals to 16, a square equals to 9, but b square greater than a square. Now in that case the ellipse is a vertical ellipse. Vertical ellipse. Now required distance between foci. For vertical ellipse, distance between foci equals to, distance between foci SS dash equals to 2BE, 2BE, or that equals to 2 into BE equals to square root of b square minus a square, or that equals to 2 into square root of, here b square equals to 16 minus a square equals to 9. Now that equals to 2 into square root of 16 minus 9 root 7, 2 root 7. The distance between foci of the given ellipse equals to 2 root 7. Then first option is correct. First option. The eccentricity of the conic 36x square plus 144 y square minus 36x minus 96.5 minus 119 equals to 0. Minus 119 equals to 0. Now, for finding eccentricity, actually the given equation converted into standard form, and eccentricity E equals to square root of a square minus b square by a square. Now, in that case, just to take in coefficients of x square and y square, which is greater, that is a square. Now, a square equals to 144. Here in coefficients of x square and y square, which is greater, that take as a square, smaller one take as b square. Now, b square equals to 36. Now, eccentricity E equals to square root of a square minus b square by a square, or that equals to square root of 144 minus 36 by 144, or that equals to square root of 108 by 144. Now, that equals to square root of 36 3 times, 36 4 times, or that equals to root 3 by 2. Root 3 by 2, or directly only under root of 3 by 4. Third option is correct. Under root of 3 by 4. Third option is correct. The latest rectum of an ellipse is 1/3 of major axis. Latest rectum of an ellipse 1/3 of major axis. Then its eccentricity. Now, length of the latest rectum of the ellipse equals to 2b square by a equals to 1/3 of major axis. 1/3 of the major axis given, but length of the major axis 2a. Now, 2b square by a equals to 1/3 of 2a. 2 get cancel. Now, 3b square equals to a square. By cross multiplication, we get 3b square equals to a square. Now, 3 into, but b square value a square into 1 minus c square equals to a square. Now, a square cancel. 1 minus c square equals to 1 by 3. 1 minus c square equals to 1 by 3. Now, 1 minus 1 by 3 equals to e square. Now, for implies e equals to under root of 2 by 3. Now, eccentricity of the ellipse equals to under root of 2 by 3. Now, second option is the correct. The minor axis forms an equilateral triangle with vertex at the end of the major axis. Then eccentricity of the ellipse. If suppose ellipse A dash are vertices, B dash is minor axis. But minor axis forms an equilateral triangle at one end of the major axis. Means triangle AB dash is an equilateral triangle. Required eccentricity of the ellipse. Now, triangle AB dash is an equilateral triangle. Now, semi angle equals to 30 degrees. In equilateral triangle, each angle equals to 60. Now, semi angle equals to 30 degrees. Now, in triangle ACB, angle C equals to 90. Angle C equals to 90 degrees. Now, always a distance between center and one end of the minor axis or CB equals to B. Similarly, distance between center and one end of the major axis equals to A. CA equals to A, CB equals to B. Now, in triangle ACB, tan 30 degrees equals to opposite side by adjacent side B by A. But tan 30 degrees value 1 by root 3 equals to B by A. Square and cross multiply, we get A square equals to 3B square. A square equals to 3B square, or A square equals to 3 into the value of B square in terms of A and E, A square into 1 minus E square. A square get cancel. 1 by 3 equals to 1 minus E square. For implies E square equals to 1 minus 1 by 3 or 2 by 3. Eccentricity E equals to under root of 2 by 3. Eccentricity of the ellipse equals to under root of 2 by 3. Then third option is the correct. Third option. If the minor axis of an ellipse subtend an angle 60 degrees, at each focus then eccentricity of the ellipse, then eccentricity of the ellipse. Now BB dash is minor axis, BB dash minor axis, one focus S or second focus S dash. Now minor axis subtend an angle 60 degrees at one focus or at second focus also 60 degrees. Now required eccentricity of the ellipse, eccentricity of the ellipse. Now take center C. Now CS is angular bisector of angle C. Now in triangle CSB, angle S equals to 30 degrees because half of the angle, because minor axis subtend an angle 60 degrees at one focus given. Now in triangle CSB, CS equals to distance between center and one focus, that equals to AE. CB equals to B. CB equals to B. Now in triangle CSB, tan 30 degrees equals to B by AE, opposite side by adjacent side. But tan 30 degrees value 1 by root 3 equals to B by AE. Cross multiply and square on both sides. A square E square equals to 3B square. A square E square equals to 3B square. Now A square E square equals to 3 into, but B square value in terms of A and E, A square into 1 minus E square. A square into 1 minus E square. A square get cancel on both sides. E square equals to 3 minus 3 E square. Now 3 E square take left side, 4 E square equals to 3, for implies E equals to root 3 by 2. The eccentricity of the ellipse equals to root 3 by 2, first option. If the distance between foci is equals to minor axis of the ellipse, then eccentricity, distance between foci. If suppose S is one focus, second focus S dash, B dash is minor axis. Now given distance between foci, SS dash equals to length of the minor axis, BB dash. SS dash equals to BB dash given. Now required eccentricity. Now SS dash equals to distance between foci of the ellipse 2AE equals to length of the minor axis equals to 2B. Now 2 get cancel on both sides, square on both sides. A square E square equals to B square. Now A square E square equals to, but B square value in terms of A and E, A square into 1 minus E square. When A square cancel, E square take left side, 2 E square equals to 1. Now E equals to 1 by root 2. Now eccentricity of the given ellipse is 1 by root 2. 1 by root 2. Now second option is correct. Second option. The equations of directrices of the ellipse: x minus 2 whole square by 25 plus y minus 3 whole square by 16 equals to 1. The equations of the directrices of the ellipse, equations of directrices. Now here h comma k center, h comma k equals to 2 comma 3 and a square equals to 25, b square equals to 16, but a square greater than b square, then equations of the directrices x equals to h plus or minus a by e. Equations of directrices x equals to h plus or minus a by e. Here h equals to 2, a square equals to 25, then a equals to 5. A square equals to 25, a equals to 5. Now required e value, e equals to square root of a square minus b square by a square, or that equals to square root of a square equals to 25, b square equals to 16 by a square 25, that equals to 3 by 5. E equals to 3 by 5. Now required equations of the directrices: x equals to h means 2 plus or minus a by e 5 by e value 3 by 5. Now if 5 goes to numerator, we get x equals to 2 plus or minus 25 by 3. X equals to 2 plus or minus 25 by 3. Now, first option is correct. If P is a point on the ellipse, 9x square plus 36y square equals to 324. Whose foci S and S dash, then PS plus PS dash equals to. Now, if suppose ellipse, S and S dash are foci of the ellipse. P is any point anywhere on the ellipse, then sum of the focal distances SP plus S dash P equals to length of the major axis 2a. Length of the major axis 2a. Now, the given equation converted into standard form. Now, x square by 324 by 9, that equals to 36 plus y square by 9 equals to 1. Now, here a square equals to 36, a square equals to 36, a equals to 6. Now, SP plus S dash P equals to 2a, that equals to 2 into 6 equals to 12. Then PS plus PS dash, or sum of the focal distances of the point P equals to 12. Second option is correct.